हेलो हेलो, आवाज आ रही है बच्चों? अनुराग ब्रो, हार्ड तो नहीं बट थोड़ा सा क्या बोलते हैं, डायरेक्ट बेस्ड नहीं आता है तो थोड़ा सा उसमें ध्यान रखना पड़ता है। और क्या है कि फिजिक्स में हम लोग एग्जैक्टली नहीं कह सकते कि ये एग्जैक्ट आएगा कॉमेड के में, ठीक है? तो रिपीटेशन जो है उसमें थोड़ा कम है, तो इसलिए थोड़ा सा हार्ड बच्चों को लगता है। बट क्वेश्चन बहुत ज़्यादा हार्ड नहीं है, उनको भी करा दूंगा, टेंशन मतलब, ठीक है? बट क्या है कि रिपीटेशन कम है। आज इस बार जिस चैप्टर से ज़्यादा आया अगले बार कम भी आ सकता है, ठीक है? तो कोई एग्जैक्टली exactly या कंफर्म आप नहीं बोल सकते कि यही चैप्टर से इतने मार्क्स के क्वेश्चन आएंगे। सो देयर वी हैव द डिफिकल्टी, ठीक है? चलो एवरीबॉडी ज्वाइन फास्ट, विल स्टार्ट इन 2 मिनट्स, ठीक है? डुअल नेचर सबने पढ़ रखा है, थोड़ा सा अच्छे से डिटेल में हल्का सा जाके समझा देंगे। एंड देन एटम्स एंड न्यूक्लियाई, ठीक है? तो ये तीनों देख लेंगे हम लोग, क्या क्या है, कितने डिटेल में है, एंड हाउ टू सॉल्व द क्वेश्चंस ऑफ दीज, ठीक है? देखो, केमिस्ट्री इज ऑलवेज अ प्लस पॉइंट। इफ यू नो केमिस्ट्री यू कैन सेव अ लॉट ऑफ टाइम। तो केमिस्ट्री पे तो डेफिनेटली फोकस करो, बट फिजिक्स को भी छोड़ो मत, ठीक है? बहुत डेप्थ में नहीं जाना है। जो इतना आप लोग कर लो कि फॉर्मूला सारे चैप्टर का, जो बेसिक एनसीईआरटी के फॉर्मूला है, एग्जाम्पलर में जितने फॉर्मूला है, ठीक है, वो सारे आने चाहिए। अगर इतना आ गया तो आप 45 प्लस स्कोर कर दोगे। 15 मार्क्स थोड़ा प्लस माइनस होगा, बट 45 प्लस तो कहीं नहीं जाएगा। तो फिजिक्स में भी किसी भी चैप्टर का फॉर्मूला कम से कम मत छोड़ना, ठीक है? हर चैप्टर का अंडरस्टैंडिंग एंड फॉर्मूला होना चाहिए। चलो, हाय मैम। चलो, समीक्षा मैम ज्वाइंड। 2 मिनट दो बच्चों, हम लोग स्टार्ट कर देते हैं, ठीक है? नो इश्यूज ब्रो, कोई दिक्कत नहीं है, बट मेहनत करो, ठीक है? और अच्छा रिजल्ट लाओ, बस यही उम्मीद है आप लोगों से। चलो, लेट्स सी थोड़ी देर में स्टार्ट करते हैं बच्चों, जल्दी जल्दी आ जाओ। चलो let's start बच्चों. So first, dual nature, बहुत ही simple सा chapter है. The chapter is very simple. ठीक है. So what we need to learn in this chapter for CT and COMEDK? Let's see. Okay. First, the first thing in this topic is electron emission. What do you mean by electron emission, students? Very simple thing. We'll just write in a short note form. What you have done? This is some surface of any metal. Okay. This is the surface of any metal. You have given some energy in the form of, let's say, light. You can give in any other form. I'm assuming that you have given in the form of light. Okay. So here the electron is there. It is absorbing the energy. And once it has absorbed the energy, it is coming out. It is coming out. Okay. Clear? Now, what are the different ways of giving the energy to electron? Okay. We'll see about all that and we'll talk in details for this chapter. Okay. So first, we could have given by heat. Okay. So it is by applying the heat, thermo emission. What is thermo emission? The moment you apply the heat, okay, to a metal body, the electrons, they absorb the energy from the heat part, and then what they do, they break the metal surface, whatever the energy with which the metal was holding it, and they come out of it. Now this is the first part with the heat. What else way we can do? See, an electron was sitting inside a metal quietly and the metal is holding it. Now suddenly what you did, you applied a very strong field here. So the moment you have seen a very strong electric field here, a positive charge, so what it will do? It will be attracted, so it will break the metal part and it will come out of the surface. Okay. So second is field emission. Means you apply a very strong field and you bring out the electron. Clear? This also you can do. Third, photo emission. Photo means send a light. Light has energy. That energy, when these two will collide, the photons and the electrons, when they collide, what will happen? The electron will take the energy of the photons and then they will come out. So that is photo emission. And the other is secondary. What is secondary? One more. See, let's say 1,000 people are running, 1,000 people are running, 1,000 people they are running, and one person is standing. So when the crowd will come, what they'll do? They'll just push him and then they'll run. So like that, if a lot of electrons are coming, so in between some standing electrons, if they are there, they'll be just pushed and they'll come out. Clear? So these four ways we can easily take out the electron from the metal surface. Clear? Very simple definitions and very simple thing. Any doubt, anybody? If you have doubt, do tell me. Okay. Chalo everybody. Next, so this part is done. In this chapter, we'll be studying in detail about photoelectric emission. Now, photoelectric emission, before studying that in detail, let's read few more concepts, okay? So what is the first concept is? The first concept you have heard of the name work function. What is this work function? See, the metal which is holding, which is here an electron is there in the metal. Now what is happening? The metal is holding that electron. The metal is holding that electron with a what? A lot of affection, care and all that, correct? With some energy it is holding it. Okay. So the electron needs to be provided with minimum some certain amount of energy so that it can break the bond of the metal and come out. So that energy, minimum energy required by electron to come out of metal surface. See what happens when your friend comes, okay, they shout from top that yeah, we want to go to play. So till that time you're like, okay, you just you're what to say, pleading with your mom, you're just telling her that you want to go to play. The moment your friend came, okay, that becomes what? A very big factor. You tell your mom now that he has come, so I have to go. So what do you do like that? So that becomes, so the moment the energy electron gets, it tries to come out. And the minimum energy by which it will start coming out, that is known as the work function of the metal. Okay, clear everyone? Now it is exact dot, means for the energy required to just come out, okay, having almost nil velocity, but in reality we can't have nil velocity, but still, okay. So the minimum energy required by the electron to come out of the, or you can say zero kinetic energy, but in reality it's not zero, it's very 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 minimal because it has to come out also. Okay, chalo, done this part. Next is, so the moment we talk about work function, energy is there, we can talk about frequency also. So we'll read once, we'll do one experiment. One of our friend buddy, he did an experiment, sir. Okay. So anybody can say who did the first experiment and got to know that by putting light on a metal surface, we can bring out electron. Anybody in the chat section who can tell me that, sir, this sir was the first person who told us that yes, if you illuminate a metal surface with some light, you can bring out the electrons. Anybody? Let's see. Have you heard of this name? So Henry Hertz, correct Vimal. Okay, he was the first person. Okay, what he was doing some experiment related to electron emission, and suddenly that was a coincidence. What is a UV lamp was there earlier? UV lamps were like very trendy, and that suddenly fell on the, what is it? The light suddenly came on the metal surface, and he saw there was a bit small spike in the number of electrons coming out. So first he thought maybe it is just a coincidence. Then he did it purposely. Then he said, oh, that's something. Okay, whenever I'm putting up light, I'm getting more number of electrons. Then two of his buddies, okay, Hallward sir and Leonard sir, they did experiment in detail, okay, to find out how these things affect and how much also, okay. So we'll see that experiment, what they have done of the photoelectric effect. Very simple experiment is that they have taken this like a glass tube, okay. They have put up two plates. One is the emitter plate from where electron will come out, and the other is the collector plate from where they'll be able to know that if the electrons are coming out and they're collected or not. So what happened is he allowed the light to come. Now the light came and hit the metal surface. The light came and hit the metal surface. So the moment light came and hit the metal surface, what will happen? If it is getting enough energy and electrons are getting energy more than the work function, okay, so what they will do? They'll start coming out. They'll start coming out. Now already our positive potential we are maintaining here. Let's say for the timing we maintain the positive potential. So the electrons will be going towards the positive, correct. And in the collector we'll be able to see the result. Okay, yes, electrons are coming, very good. Okay. So now let's talk about in detail what he saw and what are the things he did. Okay. So when he was doing all this, okay, one more term popped up was cutoff / threshold frequency. Now understand everybody, very simple. Okay, the story is very simple. What is the story is that light particle which is coming, these are what? Photons. Okay, photons of light. They have certain energy, correct? And how is the energy formula given? E is equal to h nu. H is Planck's constant and this is what? Frequency. So this person is constant. So energy depends on what? Frequency only. So the moment we defined that there is a minimum energy to take out the electron, so from there we got to know there is a minimum frequency also, frequency below which emission doesn't take place, below which emission of electron doesn't take place. Correct. So this minimum frequency was known as the cutoff or the threshold frequency. Okay. So what is this frequency? The minimum energy basically that is required. Okay, and that the photon is transferred to the electron to come out. So basically this energy is going where, students? In overcoming the work function. In overcoming the work function. Nothing more than that. Clear to layer. Very simple, very easy concept. Anybody doubt anything? Small, big, large? Tell me. Chalo, nobody doubt. If anybody has any doubt, do tell it. Okay, very simple stories are there. Okay, chalo. Next story will be learning about what things we can affect. Okay, so what they did is they were also like physicists. Okay, so they said we can't sit idle. No, we have to do something or the other. Correct. So what they did first is this is photocurrent. What is photocurrent, student? Anybody in the chat section? What is photocurrent? And what do you mean by intensity? What do you mean by intensity? And let's clear it once for all. What is the difference between intensity and frequency? What is the difference between intensity and frequency? Okay. Thanks, Samiksha ma'am. And other people too say yes, no, at least. Okay. So I'll be able to understand something is going inside the head. Okay. So intensity means people what? See, in this area, if 10 photons are coming and attacking, so what is the intensity? Number of photons per unit area is known as intensity. So here basically we talk about the number of photons divided by area, per unit area you can say. In one particular area of 1 meter square, how many photons came? So if say, let's say for the first light 10 photons came and for the second light 100 photons came. So we can say this light is more intense. Can we say, students, this light is more intense? So many of photons in so small area, correct? Let's say you became a very big hotshot. Okay, you cleared KCET and COMEDK with a rank top 100. What happens? Your house is filled with what? A lot of people. So the intensity of people increase in your house, correct? So the number of people basically. So next is frequency. Frequency means this photon which came, how strong it is, how energetic it is, how energetic this photon is. Okay, how energetic this photon is. Doesn't matter how many of them came. Means it's like our Indian Bollywood hero. Okay, so how strong they are. Okay, that is important. Clear? Even if the number is 1, that is more than enough to take care of the whole army. Correct? So that is the thing here. So frequency when we talk about, it's basically what, student? How strong or how energetic the photon which is coming and attacking the metal surface. And the moment we talk about intensity, we don't talk about how energetic the people are, but we talk about the number, how many number of people they came. Clear, everyone? Intensity shared means only just number. Intensity, simple words, means more number. Frequency means how strong you are, how strong the energy, or in terms of photons, how energetic the photon is, how much energy does it carry. If it is more energetic, so more frequency. If it is less, so less frequency. Clear, everyone? What is the difference between intensity and frequency? Yes or no, everybody? Because a lot of graphs will come, so there you need to know. If I am changing the intensity, what will be the change? If I am changing the frequency, what will be the change? Clear, everyone? Clear, everyone? Chalo. Next, let's talk about the next part. I'm giving you a graph. Let me who can explain. So what do you mean by this? Next, we talk about photocurrent. What is photocurrent? See, normally whenever the electron is going from negative plate to positive, they're constituting current. Very good. That's normal current. What about photocurrent? Photo means light. The current which we are getting through the use of photons. That is known as photocurrent. One second, student. Chalo. Till here correct. Photocurrent, we are talking about photocurrent means the current that we are getting due to the use of photons. Photons, due to the use of photons, extra electron will come. So that extra electron, how much current they are putting up, how much current they are giving, that is photocurrent. So the moment we increase intensity, students, the moment we increase intensity, what will happen? Photocurrent will increase. Photocurrent will increase. Clear? Now you will say, sir, am I changing the frequency? What is the condition here in frequency? Here the minimum condition of frequency is the frequency of whatever photons they are coming, it is more than the threshold. It is more than the threshold. Clear? Let me give you two graphs. Let's see how many people can draw a correct graph. First is frequency is less than threshold frequency. Then you have to draw the photocurrent versus intensity graph. And frequency is greater than threshold frequency. Then you have to draw the photocurrent versus intensity graph. Let's see, do it. How many people try it and tell me what will be? Come on, fast, students. Let's see, try you. It's very simple. Just I've given to think on it and very simple question I've given. A very simple question I've given, nothing very difficult, tough or something. Okay. Very simple and very easy. Because if you clarify all this thing, the moment we'll start solving PYQ will be like in your tips of fingers. Okay. Chalo. What will be the graph? You can tell it. So parallel to straight line, not parallel, zero, something, whatever it is. Chalo, 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 bachcho, fast. Chalo, I'll tell. See, if my frequency is less than threshold, okay, if my frequency is less than threshold, how much I increase the intensity? How much I increase the intensity? Photocurrent won't change. Photocurrent won't change. Because what? The frequency is not enough to take out the electron. The frequency is not enough to bring out the electron. So what will happen in this case? How much you increase the intensity? How much you increase the intensity? It will always be what? Like this. It will always be the photocurrent will be zero. The photocurrent will be what? Zero. In the second case, once we know that whatever the photons they are coming, they have so much of energy, they can take out the electron, then it is directly proportional. Then it is directly proportional. Clear, everyone? Or it went a bit bouncer, students? See, understand like this. Here the photons which are coming, they're very high energy. So each photon which is coming and attacking that what you say electron, giving the energy, and electron is running free. In this case, the photons which came, they have like almost dead energy. So when they went and talked to electron, the electron said, illa, illa, I won't go out. You don't have the energy required. Okay. So done. Even if 100 people come, same thing. Clear, everyone? Clear everyone? Yes, no, the graph, both the graphs are clear. Both the graphs are clear. चलो हाँ ना बच्चों कुछ तो बोल दो. समझ आया? यस. नहीं समझ आया? नो. और डाउट है तो डी डाल दो. नो इश्यूज. चलो नेक्स्ट we'll talk about one more stuff, very 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 important. We'll talk about one more thing which is very 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 important. What is that? We'll talk about the potential, and basically we'll talk about stopping potential. What is this stopping potential? Okay, and how did this concept came up? So the concept is very simple of stopping potential. Concept is very 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 simple for stopping potential. See here, this was my glass. This was my plate. This is my emitter plate. This is my collector plate. A photon came and attacked this electron, and attacked the electron in the metal plate. So electron started coming out. Electron started going out. Now if I apply a positive, what will happen? They'll be more attracted. Even if they have less energy, they'll be like, oh, come on, let's go. There is a free food in the marriage ceremony. Correct? We'll go. Correct? Now we said, okay, that is the condition. Okay. Hi, lucky bro. So that is the condition. What we can do, instead of putting a positive potential, what if I start putting a negative one? What if I start putting a negative one? They'll say, yeah, marriage ceremony is there, but they're checking the what? The cards. They're checking the cards. Cards is only allowing those people who has proper what? Marriage ceremony cards. Otherwise, they're not sending us inside. So what is happening is now restriction came. It is also negative. This is also negative. So what will happen? They'll repel. If it is not that much, if it does not have that much of energy, it will go just go this side. Correct. So what if we make it so strong, so strong, so strong? A time will come, even the electron with the maximum kinetic energy, will be pushed to go back to the metal. Will be pushed to go back to the metal. So that potential, the potential for which the maximum kinetic energy electron is sent back to metal is known as stopping potential. There is also one more definition, same only. The potential for which there is no emission means once they are back to the metal means no emission happened. So the potential for which there is no emission also we can write. Clear everyone? Clear everyone? About stopping potential, everybody clear? Chalo. Let me give you a graph. So the graph between here is stopping potential and here is intensity part. So what will happen if I see this graph? Even though I'm increasing the intensity, the stopping potential remains the same. Can anybody define me why? Even after increasing the intensity, though this graph has intensity I1, I2 and I3, where I3 intensity is more greater than I2, greater than I1. But why the stopping potential is not changing? Anybody? Anybody? Come on fast. Tell me. Come on fast students, tell me. This graph, who can explain an NCERT question? Basic, simple, very simple. What I'm telling is, though I'm increasing the intensity, but the stopping potential is not changing. Why, students? Describe me fast. Don't Google it. Without Googling, tell me. Whatever comes in your mind. Now what we are trying to say is, now in this case, see, we have put up a stopping potential of minus 100 volt, very strong. So what it is doing is, it is not allowing the electron to come out of the metal surface. Now what we did, we sent an, what do you say, electron with intensity means 10, means 10 photons came to bring out the electron. But what happens, photon electron interaction is one way, one collision, okay, head on. So let's say one photon came and collided with one electron, but electron said, bro, see, you don't have that much of energy, okay, even though 10 people of you have come up, but when you transfer me the energy, that is not enough for me to overcome this strong fellow, okay. So what they'll do, they'll not come out. Even if you send hundreds of them, doesn't matter, until unless their energy is more or frequency is more, we can't do anything. Clear? Even though, what happens, if a weak 1,000 weak people also go, they won't be able to persuade a strong person. So same thing here, since we have applied so strong potential that the weak, even if we have increased the intensity, doesn't matter, but only weak people we are sending, but more in number, they're not able to bring out the electrons. So that's why stopping potential remains same. That's why stopping potential remains same. Clear, students? Clear, students? Clear, students? Clear? Yes or no? Next is the concept of, next there is a concept of saturation current. What is saturation current, students? What is saturation current? See, every metal has a fixed number of free electrons. So the maximum electrons that can come out, okay, that will give me the max current. After that, from where metal will produce electron, correct? So whatever it has, it will only give that one. No, it can't beg, borrow and steal from somebody else, correct? So in that case, the maximum current that I'm getting, that is known as saturation current. Okay, chalo. Next, you will draw frequency versus if I'm doing stopping potential. So if I'm doing stopping potential, if I'm changing the frequency. So first my frequency was V1. So stopping potential is here. Next frequency is V2. Stopping potential is more. Next frequency is V3. Stopping potential is again more. Correct. So by increasing the frequency, the maximum energy of the electron also increases. So we need to apply very strong negative potential to stop it. So if I'm changing frequency, stopping potential will also change. Clear everyone till here? Clear everyone till here? Clear? Now everybody understand the energy, kinetic energy K max can be given for the electron, can be written as two forms. One is half m into V max square, the velocity form, or EV naught also. Okay, an electron charged up with a or accelerated by a potential of V naught. Both the ways we use it, both the ways we will be using it. Anybody doubt till here? Anybody doubt till here? Clear? 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 Chalo. Next we'll talk about stopping potential and frequency for two different. Let's say the first one has a frequency V naught, okay, and the other one has this one V1. Clear? So what you can see here, the second metal has how stopping potential depend on frequency. You want to ask Lucky, how stopping potential depend on frequency? Very simple, no, bro. Come to this example. Come to this one, the light body. Okay. Anybody else has the doubt how stopping potential is dependent on frequency? So what you do? Let's say you brought a photon of energy. How much of frequency? Let's talk about some 20 frequency. Okay. So when you brought of that, it gave some energy. So K max is directly proportional to this frequency 20, and K max stopping potential is directly proportional to what? K max. More kinetic energy, more we need the what do you say, potential to stop it. Now let's say another photon came whose energy is 100. So K max of that will also be what, more. So stopping it potential means the electron which is coming out of the metal, that is also very heavy and very strong. So in order to stop it, you need more stronger. No? Yes or no, Lucky? Yes or no, Lucky? Got it? Got it, students? Everybody till here? Anybody any doubt? Anybody any doubt? Sure. Next is, we talked about stopping potential for two different ones. One is for A and for B. So here we see the frequency for the B part, we are giving it more. Frequency of the B is more. So whose work function is more? Whose work function is more? Tell me. Anybody? For metal A, the work function is more. For metal B, work function is more. For metal A, work function is more, or for metal B, work function is more? Which one? Tell me fast. Come on, come on, come on, kids, fast. Come on, fast. Nobody said. See it, this has a frequency, higher frequency, this has a lower frequency. Clear? So here, in order to bring out the electron, I'm putting more energy. So work function has to be more. No, definitely B1. Correct, Pavitra ma'am. Clear, everyone? Clear, everyone? So everyone got it till here. The first topic is done. First topic of dual nature is done. Everyone got it till here. Next, we'll do Einstein's photoelectric equation, okay, laws, and then derivation of the formula. And then this chapter will be done. De Broglie and all done. Clear? Clear? Everybody till here go through, any doubt, anything, do tell me. I'll be back in a minute, okay? Now let's see next. Now everybody, Einstein's photoelectric equation. What is this? What did he said? Very simple thing he said, and very simple and easy thing. What did he say is, see, this is a metal surface. This is a metal surface. And here one electron is sitting quietly. So what happened is a photon came, a photon with large energy came, attacked the electron, and then after that the electron came out. After that the electron came out with K maximum. Clear? Clear? This is the story that happened. So what he said is, see, the energy of the photon is spent in two things. The energy of the photon is spent in two things. What are those? First, to overcome the work function of the metal, to overcome the metal bond, because metal is holding the electron. So first part of the energy went in to break that. Okay. Second, whatever the extra energy was left was given in the form of kinetic energy, was given in the form of the electron took that energy as a form of kinetic energy and came out. Clear everyone? Clear everyone? Clear everyone? So what he said is, the first energy of the photon, okay, is equal to, spent in two ways. Instead of work function, I can write h nu naught, correct? Plus kinetic energy can be written as what? Half mv square, half mv square, correct? Now this kinetic energy for electron can also be expressed in the form of, students, ev naught. Ev naught. What do you mean by ev naught? An electron, we kick it, or basically we accelerate with a potential of v, with a potential of v. Then it acquires energy that is known as ev. Clear? Chalo. Got it? Got it? Now after that, we wrote in terms of this, h nu is equal to h nu naught this. So now one more term we can write, half mv square, we brought it this side, is equal to h nu minus h nu naught, h nu minus h nu naught. So I can take h common, nu minus nu naught. Till here anybody doubt? Till here anybody doubt? Nobody? Chill? Chalo. Let's see next. Then what I can do, I can write in terms of kinetic energy is also equal to ev naught, that is also equal to half mv square, and that is also equal to, we know h nu frequency can be written as what? C by lambda. Frequency can be written as what? C by lambda. So can I write this as h into c by lambda minus c by lambda naught, c by lambda minus c by lambda naught, correct? So this whole thing, kinetic energy, can I write it in this form? Kinetic energy is equal to hc by 1 by lambda minus 1 by lambda naught. This also formula. Got it everybody? Got it everybody? Do tell me if you have any doubt. Come on, fast kids, fast. Any doubt? Do tell me. Clear, everybody? The picture of Einstein's photoelectric equation is clear. A lot of questions will be easily solved by using this. Clear? Anybody has doubt? Do tell me. If you don't have doubt, then balle balle. चलो चलो बच्चों, यहां तक समझ आ गया सारे बच्चों को? Clear? Clear? Now it's time to drop a small trick. What is that small trick? Nothing trick, bro. What is it? E is equal to h nu. E is equal to h nu. And that is also equal to what? H c by lambda. So this value, I already know h value, Planck's constant, I already know speed of light. If I multiply them, I'll get a formula. E is equal to 1243 by lambda electron volt. And lambda is in terms of nanometer. Lambda is in of nanometer. You can write this formula. A lot of place we can use directly this and get the answer. Directly this and get the answer. It also suggests us that energy is inversely proportional to wavelength. Energy is inversely proportional to wavelength. Now if I compare a red light and a blue light, which one will have more energy? If I have a photon of red light and a blue light, which one will have more energy? Come on public, टेल मी। चलो बच्चों जल्दी बताओ किसकी एनर्जी ज्यादा होगी? विच वन विल हैव मोर एनर्जी, द रेड लाइट और द ब्लू लाइट? कम ऑन फास्ट। नो आंसर। Come on, tell me one question, bro. I've asked very simple questions, students. Which one will have more energy, red light or blue light? One second, student. I'm just getting call. One second. Answer, people. Which one will have more energy, red or violet? Red or violet? Fast. Nobody answered. Come on, people. Chalo, let's see. Correct. Energy is inversely proportional to wavelength, sir. Then in that case, what will happen? Red has the maximum wavelength, so least energy. That's simple. Correct. So which one will have more energy? Violet. That's it. Was it that difficult, student? No, then why maybe, ma'am? Even if you are wrong, be bold in that and say with confidence, okay? Chalo. Clear everyone? This part everybody cleared? This part everyone clear till here? Anybody doubt till here? Anybody has any doubt till here? Chalo. Clear? Chalo. Let's see next. Chalo. Next part is our de Broglie sir. Now de Broglie sir, what he said is, he said, I'm also studying physics. Let me contribute also something. So our de Broglie sir, okay, from wave nature, what he said? He said that lambda, what I found it out is, lambda is equal to h by mv. Lambda is equal to what? H by mv. All these formulas are very important. Okay, I'm just giving only crisp formulas which is required for you for the exam. Lambda is equal to h by mv. He said, okay, chill, no issues. So he said, okay, if you're writing h by mv, can you write h by p? He said, okay, no issues. Same thing, no. No, he said, let's say kinetic energy is equal to, we already know it is half mv square. So what is the relation with momentum? He said, okay, you want to find the relation with momentum? Let's do some maths. Correct. So what he said? Okay, you're good in multiplying with mass. So multiply mass both sides. Send this to that side. So 2 into m into kinetic energy is equal to what? M square v square. So he said m square v square is nothing but p square. So 2m kinetic energy. Correct. So he said momentum is equal to nothing, student, but 2m into kinetic energy. Correct. He got this relation. Correct. I will say, sir, this is one relation you got. What about if I don't want to square root and all that? And you want in what? In square only. One more relation we have. See, we got kinetic energy is equal to what? Send this 2m that side. P square by 2m. A lot of times we'll use this also. A lot of times we'll use this also when they have given us the momentum and the mass. They have given that the momentum of alpha and what you say, a deuteron, alpha particle and a deuteron or a proton is this, and the mass we already know which one has more energy. Which formula you'll use? Which formula you'll use? Directly your brain should go to what? Where it should go? To this formula. Correct, everyone? What is the question they have said? Tell us which one will have more energy. A deuteron, a deuteron, B, alpha particle, a proton. Knowing that their momentum is for all three of them, they have given same or something. Okay, you already know the condition of mass, so you can do easily in that case. You can do easily in that case. Clear, everyone? I think so. It's a bit lagging, students. Correct? Is it lagging, students? Chalo, it's lagging, I bet. I think so. Because my voice is reaching first and the writing is reaching late. Chalo, let's see, let's see. So till here everybody got it. Till here everybody got it. Anybody has any doubt? We're about to end the chapter. We are about to end the chapter. Chalo. Now let's see. Now next is we got lambda is equal to h by p. So can I write lambda is equal to h by this value 2mk root under of 2mk. In place of kinetic energy, I'm just writing k. Okay, understand it's k only. And that is also equal to, I told you whenever energy, kinetic energy, YouTube is not receiving enough video to maintain smooth streaming. As a such view, open, okay. Poor connection, poor connection, poor connection. Hello. Hello students, are you all able to hear this one is lagging a lot? Hello students, are you all able to hear? The stream was lagging a lot. Are you able to hear? Yes, no, yes, no. Or is it okay that side? Is it okay that side? Come on, do tell me. Hello, 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 bachcho. Hello. You can hear. What about the writing part? Are you all able to see properly? Or is it coming too delayed? Are you all able to see properly or is it coming too delayed? Hi Tarun. Are you all able to see the screen and this one very properly or is it coming too delayed? Is it coming? Chalo. Let's see. I'm writing. Okay, do tell me if it is going, if it is lagging a lot or not. Okay. Hello, hello, hello. Chalo, chalo, chalo. Yeah, we got it, bro. We got the hello part. Clear, everyone? Are you all able to hear very properly? Can we start? Okay, chalo. Let's see. So we got the value. Whenever kinetic energy is there, student, you can also use this formula root under of 2m into instead of kinetic energy electron volt. And wherever you are using electron volt kinetic energy, you can use one more thing. What is that? Stopping potential. You can use one more thing. What is that? Stopping potential. Clear? Chalo. Now let's see everybody. Now with this, if I put the values and everything, what I'll get, if I put the value of 2 mass for electron, H also, I'll get lambda is equal to 12.27 angstrom by root V, root potential. If I want, I can do by this also. If I want, I can do by this also. Screen went off. Screen went off. Did screen come up? Did screen come up? Hello. स्क्रीन चला गया क्या बच्चों? जस्ट एक सेकंड देना बच्चों, एक सेकंड, जस्ट एक सेकंड. एक सेकंड बच्चों, जस्ट एक सेकंड. क्या आप दिख रहा है बच्चों? क्या जादू से प्रकट हो गया? क्या दिख रहा है स्क्रीन आप लोगों को? दिख रहा है? चलो चलो. Are everybody able to see? Are you able to hear and see properly? Yes, no in the chat section बच्चों. Chapter almost done है. Just 5 से 10 मिनट और दो. 5 to 10 minutes we are done with this chapter. ठीक है? Now okay? चलो चलो. Good. So till here all the topics, what is the basics of NCERT we have covered. NCERT we have covered and some extra topics we need to know so that we can solve more questions of CET and COMEDK. तो यहाँ तक हुआ हमारा डुअल नेचर समाप्त. ठीक है, अब आ जाते हैं हम किस तरफ, थोड़ा सा आते हैं कुछ अच्छे क्वेश्चन. क्या है, रेडिएशन वाले क्वेश्चन आ जाते हैं कि पावर क्या है. ठीक है, तो ये सारे क्वेश्चन को थोड़ा सा सॉल्व करने के लिए ध्यान दे देते हैं. ठीक है, चलो. मान लो हमारे पास एक लाइट का सोर्स है. ठीक है, जो लाइट को इमिट कर रहा है. वी हैव अ लाइट सोर्स व्हिच इज इमिटिंग लाइट. दिस इज अ लाइट सोर्स. ठीक है, नाउ इट इज फॉलिंग ऑन सम बॉडी. लेट्स इट इज फॉलिंग ऑन सम बॉडी. ओके, लाइक दिस. क्लियर? चलो, यहाँ पे n denotes, capital N denotes how many number of photons are coming. Basically intensity, number of photons. क्लियर। एंड इस लाइट की कुछ एक पावर होगी, तो p वाट का हो ये लाइट, this light will have some power, so let's say that is p watt. Clear, my diagram is bad, so don't blame me, okay, in that. चलो नेक्स्ट क्या कर सकते हैं बच्चों, अब देखो हाउ टू फाइंड आउट द नंबर ऑफ फोटॉन्स। n is equal to p, that is the power in watt, okay, by hc by lambda, 1 hc by lambda. What is the total power I'm getting divided by the power of 1 or the energy of 1 photon? So we'll get the total number of photons. So what will be the formula? P lambda by hc, P lambda by hc. Clear बच्चों? Clear बच्चों? Everybody got this concept? Everybody got this concept? We got the total power divided by the power of 1 photon. So we'll get how many photons are there? As simple as that. Clear everyone? Clear everyone? समझ आया बच्चों? चलो. If anybody has any doubts, slightest also do ask, okay? Chalo. Now, force formula, force is equal to h by lambda. Just write down this formula. You'll be using it a lot. Force is equal to what? H by lambda. Clear everybody? Clear? Now, if by 1 photon the force exerted is h by lambda, okay. So if a lot of number of photons are there, then what will be the force? Net force. Net force will be what? One photon is putting this much of force. So what about n numbers? So nh by lambda. Okay, nh by lambda. Clear everyone? And clear everyone? Till here everybody clear? Yes, no, yes, no, yes, no. Repeat this one, sir. Okay, okay, I'll repeat. First, everybody just go through once. I'll give you 1 minute. Just go through once. I'll again repeat. Don't worry. So let's see everybody. Chalo, let me again explain it again once. Okay. So what happens from a torch? Light is coming. Let's say this is a kind of black body. Let's take it. Okay. So it is absorbing, not letting any light to go out. Okay. So this is like the torch is putting some P watt. Okay. Now we want to find out what is the total number of photons. So what we will do? What we'll do? What is the total power divided by the power of one photon? So we'll get the total number of photons. Clear? Now, how do you find force? Force is equal to what? Momentum by change in momentum by time. Because force is what? Rate of change of momentum. So force we can easily find by momentum by time. So I'm not going deep into the formula. I'm just giving the gist of the formula. Okay. So force you can find it out by h by lambda. Okay. Net force for more than one particle, because not just one particle are coming and hitting this black body. Not just one particle are coming and hitting. A lot of particles are coming and hitting. So net force is equal to nh by lambda. This can also be written as power wattage by C, and that is also can be written as what is same intensity into area by C. All these three formula we can use it. All these three formula we can use it. Clear students? Clear students? Yes, no students? Clear? Clear everyone? While doing the questions, don't worry, we'll be able to solve it. While doing the questions, we'll do it. Okay. Clear? Clear? Is it clear, not clear, students? Is it clear, not clear? Hello, hello, hello. You all there? Hello. Okay, okay. Chalo, chalo. Next one more important formula is there. Now see, in the earlier black body, the photon were going and getting stuck. YZY. What is YZY? Easy, ah. Lucky you're writing easy or YZY? Yes, sir. Okay, chalo. So see, now this case, let's say this is a case 2, where we have a reflecting surface. We have a reflecting surface. Instead of absorbing surface, we have a reflecting surface. So one particle is coming, one photon is coming and hitting h by lambda. Now it is after reflecting, it is also going by h by lambda. In this case, what is force? Change in momentum, delta p by t, delta p by t. Change in momentum by time. Time, let's say 1 second. Time, let's say 1 second. So initial momentum was h by lambda. Final momentum is minus h by lambda by 1. So that is equal to 2h by lambda. So force is equal to 2h by lambda. So net force is equal to 2p by c. Net force is equal to 2p by c. Because h by lambda we can convert in p by c form. Done. Done. Just remember the formula. No need to go too in depth and details. Only thing is, if they send a light or a photon, and photon after hitting a reflecting surface, it comes back, and they're asking what is the net force, use this formula. Clear? I'll show you how to use it. Don't worry. I'll show you how to use it. So don't worry. Okay. So everybody, we are done with the dual nature. Everybody, we are done with the dual nature. Can we start the atoms chapter? The atoms, you all have energy, no? We have to do 3 chapters. Dual nature, atoms and nuclei. Clear? Clear, dual nature, atoms and nuclei. Clear, students? Yes, no, yes, no. You want to take a break of 5 minutes, or you want to start the chapter atoms? You want to start the chapter atoms? Anybody doubt in the dual nature? Anybody doubt in the dual nature? You can raise your hands. Okay, I cannot see it, but I can still say it. Anybody doubt with the dual nature? Come on, public. Be a bit fast in reacting. We'll take a break 5 minutes. Chalo, chalo. I'll also drink hot water and come. Chalo. Let's start बच्चों. All good, ready to. सर ऑप्टिक्स कब? अरे सर घबराओ नहीं, सब हो जाएगा, 10 से पहले सब हो जाएगा. ठीक है, आज थोड़ा सा लाइट लेके जा रहे हैं क्योंकि कल बहुत सारे बच्चों का एग्जाम है. ठीक है, तो उनको होने दो, उसके बाद एग्जाम होने दो, उसके बाद क्लासेस चलते रहेंगे डेली, सुबह दोपहर शाम. ठीक है, बस आ जाना क्लास में. देखिए क्लास में आप गायब हो तो अच्छी बात नहीं है. हाँ चलो, तो चलिए स्टार्ट करते हैं बच्चों. लेट्स स्टार्ट द चैप्टर एटम्स. वेरी सिंपल, वेरी इजी चैप्टर. Now, what is there in this chapter? Atoms. Okay, let's see and figure out. Very simple, very basic things are there. Okay, and formulas are very important. कल बोर्ड एग्जाम है सर, इसलिए गायब था. ओके चलो, मैथ्स का प्रिपरेशन हो गया सारे बच्चे? जो those for those students who are giving the board exam, preparation is done. ठीक है, इसलिए थोड़ा सा ज्यादा लंबा क्लास नहीं खींच रहे थे, बट चलो आप लोग बोल दिए तो एटम्स और न्यूक्लियर निकाल ही देते हैं ना. ठीक है, मेरा तो टारगेट था आज कुछ लाइट चैप्टर करा के कल करा देते, बट चलो आप लोग रिकॉर्डिंग देख लेना. हाँ, और कोई डाउट रहा तो बस खत्म, पूछ लेना. तो और आप लोगों का बच्चों 11 से स्टार्ट होगा रिवीजन सीरीज, मिस नहीं करना. 11 से 15 लाइव रहेंगे, वी विल बी देयर अराउंड 12 to 14 आवर्स. देखते हैं कितने बच्चे कितना मेहनत कर पाते. ठीक है, एंड फॉर दोज हु आर बैक बेंचेस, लेट्स सी. चलो हो गया फ्रेश होने आया, चलो थोड़ा सा फ्रेश कर ही देते हैं ना. क्या है, एटम चैप्टर भी मस्त फ्रेश है, तो चलो देखते हैं. सो एटम वाले भैया में देखो कहानी क्या है, कहानी घर घर की जैसी है. ठीक है, so what happened in atom? A lot of people, they wanted to make how does the atom look like. Okay, what is the inside of the atom? And the first they discovered what is it made up of. Dalton sir said, he came and he said like atom is unbreakable, correct, indestructible. So he put a stop, no atom mode, say no drawing the picture of atom because you can't break it. So later we got discovery of electron, proton and neutron. Who discovered what? The revision series important concept of every chapter. हाँ bro, रिविजन सीरीज में जो जो क्वेश्चंस इंपॉर्टेंट है, अब देखो वी कैन नॉट गारंटी कि ये सारे इंपॉर्टेंट है, बट जो लग रहा है थोड़ा टफ है, थोड़ा ट्रिकी है, वो सारे कुछ को एक जगह समेट के अच्छा से बना के ब्रिंगिंग इट ऑल टुगेदर. आई विल गेट इट डन विद ऑल द चैप्टर्स, सारे चैप्टर्स का. ठीक है, वो 5 दिन में मतलब एक दर्दनाक रिविजन कर देंगे. ठीक है, बाकी आप लोग संभाल लेना एग्जाम में. कंसेप्ट हम करा देंगे, बाकी एप्लीकेशन आप पे छोड़ देते हैं. इतना तो कर ही लोगे ना? क्या बोलते हो कार्तिकेय भैया जी? व्हाट यू से कार्तिकेय? एटलीस्ट दैट मच यू कैन डू, नो? I'll get the concept and the important. Basically, what I'll do, I'll give you one question. Okay, let's say this is the question, and उसके साथ ही साथ एक concept का डिब्बा चिपका देंगे. ठीक है, तो क्या होगा, once you are done, question plus question और concept. अरे भैया और नहीं लगाते हैं, क्या लगाते हैं? प्लस लगाते हैं. जिंदगी को आगे बढ़ाना है तो प्लस लगाओ और मत लगाओ. ठीक है, if you are going to a shop or if you are going to a party, don't ask for I want this or this, I want both plus. ठीक है, चलो जस्ट किडिंग असाइड. तो क्या रहेगा आपका क्वेश्चन रहेगा, एंड क्वेश्चन के साथ उसका जो कंसेप्ट यूज हो रहा है उस क्वेश्चन में, वॉट एवर द कंसेप्ट वी आर यूजिंग इन दैट क्वेश्चन, विल पुट दैट ऑल्सो. सो स्टूडेंट्स will be comfortable. Okay, this is the concept, this is the way we have to use it. ठीक है, so you'll be feeling more comfortable and more proper revision can be done. कोशिश कर रहे हैं, बाकी आप लोग साथ दो. ठीक है, और जितने भी अपने दोस्त लोग उनको भी बता देना. ठीक है, तो क्योंकि 14 घंटा पढ़ाएंगे डेली का, तो कम से कम थोड़े बच्चे रहेंगे तो अच्छा लगेगा, ठीक है। तो कोशिश करो जितने दोस्त लोग को बता सको, ठीक है। चलो, और हाँ, लास्ट के जो 5 दिन रहेंगे, पत्थर बन के मत पढ़ना बच्चों, ठीक है। ये भी ठीक है, कम से कम कुछ बातें करते रहना, ऐसे लग रहा है कि स्क्रीन के सामने बैठा हो और बस आवाज जा रही है, ठीक है। तो उधर से भी कुछ आना चाहिए, है ना। चलो, कम से कम डाउट ही पूछ लेना, नहीं आया तो भी पूछ लेना, कोई दिक्कत नहीं, फिर से बता देंगे। आ भी गया तब भी पूछ लेना, हाँ सर एक बार बता दो। चलो देख लेते हैं अब। द स्टोरी ऑफ एटम began like this. So our J.J. Thomson, he was very famous, okay, and after the discovery of electron, okay, he said, see, I'm making and drawing the atom structure, atomic structure, and he gave what you call it as plum pudding model. Plum pudding model, pudding was very famous, okay, or watermelon model also, watermelon. So he said that the red flesh, okay, is the what, the positive charge. 24 आवर पढ़ाओ सर, उतना भी पढ़ लेंगे। चलो देखते हैं सोहम भैया जी कितना देर पढ़ते हो आप, ठीक है। चलो, चैट आना चाहिए, नहीं कि बस बोल दिया हाँ सर है, वो आधा घंटे बाद उठ के नींद से एक बार, हाँ सर आई एम देयर इन द चैट सेक्शन सर, फिर 1 घंटे के बाद हाँ सर आई एम देयर इन द चैट सेक्शन, ऐसा नहीं होना चाहिए, ठीक है। चलो, सो व्हाट हैपेंड, ही सेड everybody has seen watermelon. So the seeds, he said, these are what? The electrons, and the flesh, red flesh, is the protons, positive part. So this is the way he said the atom is, okay. But it got rejected by whom? Anybody? It got rejected by whom? Come on, fast people. जस्ट थोड़ी सी स्टोरी शेयर करेंगे, उसके बाद डायरेक्ट मेन पॉइंट पे आ जाएंगे, ठीक है, टेंशन मत लो। So it got rejected by his own student, okay. So when our Rutherford sir, he did the gold foil experiment, okay, he said no, it can't be possible. So what he did it. So he took a gold foil, okay, and he bombarded that gold foil with fast moving alpha particle, very energetic alpha particle. So what he saw in that is most of the alpha particle passed straight to the gold foil. These are all your 10th 11th concepts, okay. You have studied in chemistry also, you have studied in physics also, correct. So most of the alpha particle passed straight through the gold foil. He said, since most of them are passing straight, it means most of the space in the atom is empty, very simple. Then he saw very few got bent by small angles. He said something is there to bend it. Since he's sending an alpha particle, since he's sending a positive particle, so something positive has to be there to bend. Otherwise what will do? Negative रहता तो attract कर देता, क्या है पॉजिटिव है तो बेंड कर दे रहा है, ठीक है, थोड़ा सा धक्का. Now he said 1 out of every 20,000, somewhere 18,000, somewhere 12,000 were rebound, were rebound. So he said something very strong is there, bro, okay, at the center, and that is doing this rebound effect, correct. And he called this very strong positive thing as what? What he called it? Come on fast. अरे भैया 10th का तो मत भूल जाओ. What he called it, students? Let's see. देखते हैं किसकी तरफ से आंसर आता है. चैट सेक्शन स्लो है या आप लोग सच में भूल गए? Come on, Soham sir. Let's see. No reply as of now. Kartike, no reply. Nishat also no reply. Come on. Nobody remembered. We have learnt in class 11th, I think so, second chapter, atomic structure. In physics also we learnt in 12th. Let's see, it's a pin drop silence. Okay. Whose reply will come first? Come on, everybody. Nobody remembers. What is this central part called as? Come on, don't say. अरे इतना भी मत भूल जाओ आप लोग. Chalo, at last Kartike got some courage. He wrote nucleus, sir. Good. चलो, they said this positive charge and the strong central core is known as the nucleus. तो उसने बोल दिया क्या भैया ये तो न्यूक्लियस है, ठीक है। चलो अब इसके बाद ये तो सारे 11th के फंडे थे, ठीक है। थोड़ा सा और डीप में जाते हैं बच्चों। सो लेट्स टॉक अबाउट मोर इन डिटेल्स अ बिट। नेक्स्ट इज डिस्टेंस ऑफ क्लोजेस्ट अप्रोच। नेक्स्ट इज व्हाट? डिस्टेंस ऑफ क्लोजेस्ट अप्रोच। नाउ व्हाट इज दिस? What is this? Distance of closest approach is what? See, alpha is also a positive charge particle. This nucleus also positive. So this alpha can't come in touch here, no. So what distance it can go after which it is changing its path? Okay. So this distance till it is coming, chat slow है. Okay, okay. अरे भैया न्यूक्लियस लिखे भी तो क्वेश्चन मार्क क्यों डाला? क्या आप 10वीं पास नहीं हो? हाँ, इसमें तो कम से कम कॉन्फिडेंट रहते सोहम सर। चलो देख लो। सो दिस पार्टिकल, दिस अल्फा पार्टिकल इज गोइंग, बट आफ्टर सिंस इट इज this nucleus is very strong, okay, and it is in a very small place, very concrete, okay. So what is happening? It is pushing it back, applying a electrostatic repulsion. So what it will do? It will lose all its kinetic energy, and a time will come here when all the kinetic energy will be equal to what? Zero, and now it will be pushed back, and now it will be pushed back. So this is the concept of distance of closest approach, okay. So the closest distance the alpha particle can go, after which it rebounds, after which it rebounds. Clear? So that is known as distance of closest approach. Now what one value is there, one formula is there, just write down that formula. 1 by 4 pi epsilon naught 2ze square by k, ke. Okay. How do we get this formula? We equate kinetic energy of the nucleus is equal to what? Electrostatic repulsion between nucleus and the alpha particle. That's it. Clear? Everybody getting this concept or anything going beyond head? Do tell me, huh? Chalo, very simple. See, when the alpha particle is here and the nucleus is here, so this alpha particle had kinetic energy to go forward, and this was applying what? Electrostatic repulsion. So when these two force becomes equal, in that case what will happen? Now kinetic energy will be taken care. It will be almost zero. Now it will be sent back. So by that, using that formula, we got this part. We got this part. Clear? Chalo. Till here everybody got it? Till here everybody got it? Anybody has doubt till here? Anybody has doubt till here? Do tell me fast. Come on fast. Anyone getting a doubt till here? Till here everybody's concept is cleared. Where is the other kids? No reply from the other kids. Lucky, Pavitra ma'am. What about others? Fast. Chalo. No doubt. Good. Chalo. So till here we got it. Now after this, there were two reasons why Rutherford model failed. He proposed the model. In this model, he said, sir, only one nucleus is here. Electrons are revolving outside the nucleus. Okay. And because of this electrostatic force, they are able to revolve it around the, making a circular path. हाँ, ये फॉर्मूला क्लोजेस्ट अप्रोच का है, ठीक है। चलो, हाय समीक्षा मैम, एग्जाम प्रिपरेशन हो गया? चलो निश्चित मैम, ओके, एवरीबडी क्लियर? चलो, now Rutherford had two drawbacks. Rutherford sir had two drawbacks. Can anybody tell me what? Any hint? Very simple, very easy. Come on fast. चलो let's see. तो सोम सर ने लिखा failed to explain the stability of the electrons in a circular path. ठीक है, चलो ये भी ठीक है. Unable to explain the line spectrum. चलो ये भी ठीक है. So what happened is, first one very simple, very easy. ठीक है. So he said, and how do we explain it? At his time, one theory was there of Karl Maxwell. Okay. So Maxwell's theory was there what? Any charged particle, if it is going a circular motion, any charged particle, if it is going a circular motion, what it will do? It will radiate energy. It will what it will do? It will radiate energy. Now once it starts radiating energy, what will happen? See, right now it has energy 100 joule. The moment it is going in one circle, it will radiate energy. Now it will have 90 joule. So its radius will become less, more smaller, more smaller, more smaller. A time will come, it will fall into the nucleus. So how can that be stable? We see everything is stable, correct? So he was not able to explain the stability, correct? Now next, according to Karl Maxwell, okay, or Maxwell sir, that electron is radiating energy continuously. So it should not have line spectrum, few lines here, energy radiation, again gap, again lines here. So it should be continuous spectrum, but it was a line spectrum. He was not able to explain that. He was not able to explain that. Clear everyone? चलो आगे बढ़ते हैं. चलो नेक्स्ट आते हैं अब. आफ्टर दिस, since what you say, he saw Rutherford sir failed in his attempt, so who took charge? The student of the Rutherford sir, Niels Bohr. Okay, so Niels Bohr sir, he was also the student, and all three in the same college. Okay, so J.J. Thomson, Rutherford and Niels Bohr, three era. Okay, so what happened? Bohr came. He said no, things are a bit different. He said, okay, let's see. So Bohr's atomic model, what he said, in Bohr's atomic model, he said that when the electrons are revolving around the nucleus, they are not revolving in just any orbit. They're not revolving in any just circular path. These are very specially designed orbits known as stationary states. He put up some fancy terms, okay, known as stationary states. And these stationary states, in these stationary states, it does not radiate energy. He said directly, okay. And then he said, what is the condition to make these stationary states? We'll come to that. He said their angular momentum is quantized. We'll see about that, okay. Chalo. So next, when he said the Bohr's part, so here let's say this is the nucleus and electron is revolving, okay. He said the angular momentum, okay, is quantized, and it is integral multiple of h by 2 pi. So what is the angular momentum formula? mvr is equal to what? Integral multiple of h by 2 pi. So we got one formula from here. Next, what else formula was there? Now, in order for this electron to move in the circular orbit, it needed what? Some force. And where is this centripetal force coming from? F electrostatic was giving the F centripetal. Correct. What is the electrostatic force? This is what? A nucleus having how much charge? How much charge? Students, come on, tell me. How much charge will it have? Will it have Ze or anything else? Tell me fast. How much charge the nucleus will have? See, neutrons doesn't have any charge. Nucleus, whatever stays, that is called nucleons. So proton and neutron together, they are the nucleons. Proton has positive charge, electrons has negative charge. So we got the formula that in order for the electron to revolve around the circular orbit, the centripetal force is given by electrostatic force. So what will be the centripetal force, or what is the electrostatic force formula? K Q1 Q2 by R square. K Q1 Q2 by R square. So K Q1 is what? Ze into E by R square. And that is equal to what? Centripetal force mv square by R. So from this all we can find all the formulas, okay. Chalo, I'll not go into details. I'll just write down the formula, okay, because I know everybody has done the physics part and they know the derivation well, okay. So I'll just go with the direct formula. What are the formulas needed? So here, radius of nth orbit, the formula is what? N square h square epsilon naught pi m e square z. So everybody agrees that they can find out the radius formula, yes or no? They can find out the radius formula, yes or no? Yes or no? Everybody knows how to find out the radius formula. See, R and R will cut. We'll send it that side MVR, and we'll put up this NH by 2 pi and we'll solve it. So you all remember this formula, radius of nth orbit, correct? Everybody, they know this formula, yes or no? Do tell me, kids, fast. Everybody knows it. I don't have to explain. Yes, no, kids. If anybody has doubt, then I'll explain. Otherwise, I'll skip. I'll just directly put the formula. If anybody has doubt, do tell me. I'll explain. Otherwise, I'll skip it. No need, because I know you all know this chapter, so we don't have to. What do you say? Do it. If you want, I can just tell it fast. No issues. Okay. Chalo. Everybody knows it, so I'll just skip it. Okay. So from there, we'll get the formula. Okay. Nobody wants no? Okay. Good. So what we got in the formula here, students? Okay. So we got this formula as Bohr's formula. So we got the radius of the nth orbit. What if I want to find the radius of the first orbit? Radius of the first orbit. So in that case, what I have to do? In that case, what I have to do? So see, if you see h is constant, epsilon is constant, pi is constant, m is constant if I'm talking about an electron or something, E is constant, and Z also, if I know what element I'm using, I can take that also constant. So if I don't know what is Z, so I can say Rn, radius, depends on two things, n square by Z, okay? And if I fix Z, no, it is of hydrogen atom or something, I can remove Z also. In that case, I can say R is directly proportional to n square. Yes or no, very important, okay? If I want to go from the radius 1, first radius, to the second one, R2, to the third one, what will be the ratio change for the same element? It will be 1:2. If I go for the next, it will be what? 4:9, correct? In this ratio it will come. Yes or no, kids? In this ratio it will come. Yes or no? Correct. And if I want to find out the first one, okay, so that is also called as the Bohr's radius. Bohr's radius. What is that? That is almost approximately equal to 0.53 angstrom. If I put the value for a hydrogen atom, if I put the value, I'll get this much. Clear, everyone? This everybody knows. I'm not going into much details about it. Clear? Chalo. Clear. Chalo. Good. Let's come to velocity term. Okay. What is the velocity formula? I think so everybody knows about the velocity formula. V is equal to, we know it can be nh by 2 pi mr. Now here we'll put the r value. So what you will get, V is equal to Z e square by 2 pi epsilon naught h, okay, into n. So if you see, e square constant, 2 constant, epsilon naught constant, h constant. So V is directly proportional to Z by n. V is directly proportional to Z by n. Do not ignore Z if it is given that is not a hydrogen atom, something else. Do not just remove Z because thinking hydrogen it is this, Z is equal to 1. No, don't do that. Okay, clear? So V is directly proportional to Z by n. Clear, everyone? Clear by everyone? And this constant value, students, and this constant value Z by n into e square by 2 epsilon naught h, this is equal to 1 by 137. Can you remember? 1 by 137. This will be helpful for the questions. Okay, this will be damn helpful for your questions. Okay, clear? So, and we'll get 1c here. Oh, sorry, 1c here will be there. Okay. So the first velocity v1, if you want to find, it will be c by 137. C by 137. Clear? Clear students till here? Everybody, it's going inside head, not going bounce back. Okay, chalo. Just discussing the what is a normal formula, what is there. Okay, if you have gone through the chapter, you'll be able to understand. I'm not going the derivation and everything. Okay, now we all know how linear velocity and what is say angular velocity are related. What do we know? V is equal to r omega. V is equal to r omega, and r into omega is what? 2 pi f. If I want to know the frequency, so from here frequency is equal to what? V by 2 pi r. So I can put the value. I can put the value and get the frequency also. So frequency will be nothing but kz e square by nhr. Clear everyone? We'll get the frequency also. We'll get the frequency also. Clear everyone? Can I go to the next page? Just go through. If you want, you can write it also. Clear everyone? Clear everyone? Everybody got till here? Everybody got till here? Just the formula discussion, nothing more. Very simple, very easy things. Okay. If anybody has doubt, no sir, we want to go more in depth. Later again, I'll if needed. A lot of people are having doubt. I'll do the chapter. Nothing is there in that chapter. Okay. Clear, clear, clear everyone. चलो हाँ ना बच्चों जल्दी थोड़ा जल्दी बच्चों. चलो. Let's go for the next one. Let's go for the next one. That is orbital frequency. Frequency already we got. So what we got frequency as? If I put the value of r in terms of r we got. If I put the value of r, frequency will get it as. I'm just writing the formula m z square e power 4 by 4 pi epsilon. Sorry, no pi. 1 second. So हम घड़ी भेज के पूछ रहे हैं क्लियर सर. घड़ी भेज के पूछ रहे हो आप कितने बजे. समय नहीं बताता सर कि वो कब तक है कि नहीं. 4 एप्सिलॉन नॉट n क्यूब बाई h क्यूब. ठीक है. सो फ्रीक्वेंसी इज डायरेक्टली प्रोपोर्शनल टू m कांस्टेंट है बच्चों, z कांस्टेंट है. z कांस्टेंट नहीं है हमारे पास, e कांस्टेंट है, 4 एप्सिलॉन नॉट कांस्टेंट है और h कांस्टेंट है. सो फ्रीक्वेंसी डायरेक्टली प्रोपोर्शनल क्या है? z स्क्वायर बाई n क्यूब. ये इंपॉर्टेंट है. z स्क्वायर बाई n क्यूब फॉर्मूला में हम लोग को दिस विल बी नीडेड. ओके चलो नेक्स्ट. फ्रीक्वेंसी इज दिस. टाइम पीरियड क्या होगा? जस्ट उल्टा हो जाएगा. फ्रीक्वेंसी इज व्हाट? 1 बाय टाइम पीरियड. सो इट विल बी डायरेक्टली प्रोपोर्शनल टू n क्यूब बाई z स्क्वायर. फ्रीक्वेंसी और टाइम पीरियड क्या है? फ्रीक्वेंसी इज इनवर्सली प्रोपोर्शनल टू 1 बाय टाइम पीरियड. जस्ट उल्टा कर दो, जस्ट रिवर्स इट. क्लियर एवरीवन? नथिंग इज देयर. ओके चलो यहां तक सभी बच्चों को समझ आ गया. चलो 15 मिनट्स और दो, ये चैप्टर कंप्लीट हो जाएगा. नथिंग इज देयर इन दिस चैप्टर. मैक्स 15 मिनट्स. ओके ठीक है चलो क्लियर. नेक्स्ट एनर्जी, बहुत इंपॉर्टेंट है एनर्जी. ठीक है. सो एनर्जी ऑफ इलेक्ट्रॉन. Energy of electron, very important concept. Okay, so kinetic energy we can find it out by half mv square. I'm just writing directly formula 1 by 4 pi epsilon naught z e square by r. This is kinetic energy. What about potential energy? Minus of 1 by 4 pi epsilon naught z e square by r. Now students, kinetic energy and potential energy, will it be same or it will be double or it will be half? Let's see who remembers. Let's see who remembers fast. Kinetic energy will be how much, students? Tell me fast. Kinetic energy will be, this one will be 8. If I put the value of z, okay, and everything, I think so. 1 second. Kinetic energy will be E square by 8 pi epsilon naught r. Z E square by 8 pi epsilon naught R. Clear? And what about potential energy? What about potential energy? Potential energy is nothing but minus 2 times the kinetic energy. So it will be minus 1 by 4 pi epsilon naught Z is E square by R. Now total energy will be what, students? Added both kinetic plus potential. So what you will get? Minus E square Z E square by what? 8 pi epsilon naught R. So this formula is very important. What is that formula? See, kinetic energy is always positive. Total energy is equal to minus times of kinetic energy, and potential energy is equal to minus 2 times of kinetic energy. Clear everyone? Clear everyone? This part is important. Clear? Clear everybody? Half of potential energy, correct. Chalo, everybody got it clear? So what we got? Kinetic energy positive hai. Total energy same value as kinetic energy but negative form. And potential energy double, minus 2 times of kinetic energy. Clear everyone? Clear everyone? Clear everyone? Chalo. Next is in what do you say? In the 3 postulates given by Bohr sir, he said one more thing. First, he said a stationary state that they're revolving in orbits which does not radiate energy, and those are called stationary states. Second, he said the angular momentum of the orbit is quantized, and that is equal to integral multiple of h by 2 pi. Third, he said whenever an electron goes from one orbit to another or comes back from a higher to lower, it radiates energy in the form of electromagnetic wave. Clear? It radiates energy in the form of electromagnetic wave. Okay. Now before that, one more energy formula is there. Energy of nth orbit is equal to minus 13.6 z square by n square electron volt. This is also a very important formula because a lot of questions will be there in electron volt, and in order to solve them we need this formula. In order to solve them, it becomes easy if you remember this formula. Clear? Minus 13.6 z square by n square electron volt. Clear? Clear students? Clear students? So by this we can find out, what is the energy of the first orbit. If I put n equal to 1, the value will be what? Minus 13.6 electron volt. In the second orbit, n equal to 2, the value will be what? Minus 3.4 electron volt. If I go for the third, the value will be what? 0.51 electron volt. Okay. So like that, we can find it out all. Clear? Till here now. So whenever an electron is doing a transition, whether it is going from here to here or coming from here to here, anything, whenever it is doing a transition, it is releasing a photon. It is releasing an electromagnetic wave in the form of energy, in the form of a photon electromagnetic wave. And that energy of the photon is given by energy difference of the orbits. That energy of the photon is given by कुछ नहीं bro, nothing is there in this. आप लोग मतलब कहानी बना के रखे हो, कुछ नहीं. Atoms, देखो, modern physics is just like very small simple chapter. One day is more than enough to clarify each and everything, get it done. चलो ठीक है. तो क्या बोला इन्होंने कि whenever an electron jumps from lower to higher, higher to lower, it radiates energy in the form of electromagnetic wave, and that energy h nu is equal to energy difference between the orbital. That energy of the photon which is coming out is equal to h nu, and that is equal to energy difference between the orbitals. That's it. Clear everyone? Sure. Till here everybody got cleared. Till here everybody got cleared. Till here everybody got cleared. Chalo. Next we'll talk about the spectrum and the line spectrum and all that. Okay, don't worry. Okay. So whenever an electron is jumping from here to there, there to here, okay. So we'll talk about the line spectrum of hydrogen atom. The line spectrum of hydrogen atom. Okay. Just give me 1 second. I'll find out one diagram is there with me. I'll show it. Okay, 1 second. देखते हैं डायग्राम से आप लोगों को कितना समझ आता है लाइन स्पेक्ट्रम का डायग्राम। चलो लेट्स सी बच्चों, दिख रहा है? चलो, तो स्पेक्ट्रल सीरीज ऑफ हाइड्रोजन एटम, थोड़ा ज्यादा ब्राइट कलर यूज कर दिया यहाँ पे, ठीक है। चलो देख लेते हैं इसमें क्या है। सो ईच स्पेक्ट्रल लाइन corresponds to an electronic transition to a particular state. What does it means? That each spectral line tells us about from where to where the electron is going or from where to where the electron is coming. Clear? So we have 5 regions or series. Okay, if anything from anywhere is coming back to the ground state, coming back to the n equal to 1 level, then we call it as Lyman series. Then we call it as Lyman series or Lyman region. If from anywhere you are coming and dropping it equal to n equal to 2, then it is Balmer. Then it is Balmer from anywhere. If you are coming and dropping it for n equal to 3, then it is Bastian. And from 4, bracket. And fifth is Fund. And fifth is Fund. Lyman series, you have, it falls under the UV region. Balmer is the visible one. Bastian, bracket and Fund, all three infra. All three infra. Clear everyone? Till here everybody clear? Till here everybody clear? Yes, no, students fast. Till here everybody clear? Now sometimes they'll give you a question to find out the number of spectral lines or the transitions. Okay, so what you can do, n into n minus 1 by 2, you can use this formula. Like if an electron is doing a transition from n equal to 6 to n equal to 1, how many number of spectral lines will be there? You can just put it here. 6 into 6 minus 1 by 2. So 2, 3. So we can have a lot of lines. Correct? Done. Clear everyone? Clear everyone? Chalo, chalo. Done. Clear everyone? Chalo. Now, so we all are clear about this. Next is, oh, this looks like a blackboard. Chalo, next is, yeah, it's good. So H nu is equal to E initial minus E final. Just now we said that the energy of the photon is equal to what? The difference between the two orbitals. Okay. From there we get the formula 1 by lambda equal to m e power 4 8 epsilon square ch cube into 1 by n final square minus n initial square. From which orbital, final orbital, to which initial orbital it is coming, this is the formula. And this whole thing is nothing but our Rydberg constant R, okay, whose value we already know. So 1 by n final square minus n initial square. Clear everyone? Clear everyone? Clear everyone? Chalo. We got this. We all know the value of Rydberg constant. One last topic. Just 2 minutes I'll take. One last topic. What is it? De Broglie explanation of Bohr's second postulate. De Broglie. Oh. Explanation. De Broglie. Explanation to Bohr's second postulate. So what did he say? Let's say this is a circle part. De Broglie said, sir, he said is like this. What do you mean by this, sir? He said that in an orbital it will always have integral number of what? Integral number of Come on, anybody? Can you say the word? Spill out the beans. Integral number of de Broglie waves, nothing more than that. So whole circle, what is the circumference of the circle, everybody? If you have read in class 2, at least you should know this much. What is the circumference of the circle formula? चलो बच्चों कम से कम इतना बता दो जल्दी से. Circumference of the circle formula क्या है बच्चों? Fast. Nobody knows? Wow. Pin drop of silence for circumference of circle. So let's see, circumference of the circle, students, is 2 pi r. Karthike, good. So 2 pi r, he said in the whole circumference, we can have what? Integral number of de Broglie waves. Integral number of de Broglie waves. So from here, we can get 2 pi r is equal to n into lambda is equal to what? H by mv. So from here, if you send that side, mvr is equal to what? Nh by 2 pi. So this is what? Our, what is it? Bohr sir said what? The angular momentum is what? Quantized, and that is equal to what? Integral multiple of h by 2 pi. Integral multiple of h by 2 pi. So what did de Broglie sir proved? That Bohr's second postulate is correct. Clear everyone? Clear everyone? ये कंसेप्ट क्लियर हुआ बच्चों या थोड़ा सा ब्रेन के ऊपर से चला गया? अरे सर इतना टाइम लोगे तो कैसे चलेगा? देखोगे ट्रेन पार हो गई है, ठीक है, वो जब में वेट वाला हाल हो जाएगा. ठीक है, चलो नेक्स्ट आते हैं. अब थोड़ा सा एक बार देख लेते हैं लाइमन बामर पास्चन ब्रैकेट पी फंड. बहुत सारे बच्चों को इसमें डाउट रहता है. तो लाइमन में क्या होगा बच्चों? 1 बाई लैम्डा इज इक्वल टू आर इंटू 1 बाई 1 स्क्वायर. ये देखो फाइनल स्टेट है. लाइमन में आप लोगों को क्या बताया गया था? फ्रॉम एनी प्लेस इट इज कमिंग एंड लैंडिंग टू द फर्स्ट ग्राउंड स्टेट. So that's why this formula is r into 1 by n final square minus n initial. From any place we are coming and landing into the first. That means Lyman. ठीक है. Balmer means what बच्चों? Balmer means what? So 1 by lambda will be equal to what? R into 1 by 2 square minus 1 by n square. Correct. It will come and lie to the second orbit. So same way, Paschen will be what? Paschen will be what? R into 1 by 3 square minus 1 by n square. Bracket will be what? R into 1 by 4 square minus 1 by n square. And fund will be what? P silent up. R into 1 by 5 square minus 1 by n square. Correct? Everybody got it? We are done with the chapter atoms. Okay, we are done with the chapter atoms. Anybody has any doubt? You can raise your hand. You can say, sir, I have a doubt. Okay. So if you have, anybody has any doubts, do tell me. Atom is done. How many has the energy to do the chapter nuclei? How many have the energy to do the chapter nuclei? A very straightforward question, and I need a straightforward answer. चलो समीक्षा मैम समझ तो आ गया, कल एग्जाम भी है. ठीक है, बेस्ट ऑफ लक. Best of luck to all those, okay, for writing the exam tomorrow. Write properly and get 100 out of 100. Chalo. So best of luck everybody, okay, for those who are writing the maths exam tomorrow, okay, do well, do not do any silly mistakes. Chalo. Samiksha ma'am just erased it. What if I'm telling yes for the next class? Chalo, okay. So we'll take a break. Let's see after the break how many people stays. So we'll take, what do you say, finished off the what? Nuclei also. Once we started, let's not end it. Okay, it's very simple and easy topic. Maximum 45 minutes I'll take. Okay. 40 marks है तो वही 100 है, समझ लो. Proportion. If 40 is equivalent to 100, Try to get 40 out of 40. Take 40 minutes. 40 minutes will be done. No issues. 40 minutes में हो जाएगा ब्रो, कुछ नहीं ज़्यादा इसमें, ठीक है, जल्दी भी हो सकता है, ऐसा कुछ नहीं है, ठीक है. सो क्या बोलते हो, 30 मिनट्स में कंप्लीट कर दे बच्चों? We can complete in 20 minutes also, very simple. The concept is very 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 simple. मैं कल रिकॉर्डिंग देख लूंगा सर न्यूक्लियर का, कोई दिक्कत नहीं, आप जाओ थोड़ा सा कूल माइंड होके. एवरीबडी फॉर टुमारोज एग्जाम व्हाट इज इंपॉर्टेंट इज what you know first, do it. What you don't know, don't waste much time on that. First finish up, because maths paper always 90% of the time it comes lengthy. So first go through the maths part. What you know properly 100% finish it off. After that, whatever time you'll have left, in that clear off the whatever is left. Okay, ठीक है. एक क्वेश्चन को देख के ज्यादा टाइम नहीं बर्बाद करना, ठीक है, because 2 markers are there, okay, most of them, and few 3 markers are things also there. So don't waste a lot of time. Okay, yeah, I'll continue now only. Okay, chalo, bye Swam sir and others who are writing exam, best of luck. Okay, just give me 1 minute student. Okay, 1 minute, I'll be back. Okay, I'll drink water and come back. Till then you don't go anywhere, just revise the topic atoms. Okay, I'll be back in a minute. पेपर के लास्ट में सैम क्लासेस लिख के आ जाओगे. चलो, rest all is there, only one person is there. We'll start. Who all is there? जल्दी बताओ, जल्दी बताओ. Chalo, let's start with the nuclei. Everybody ready? Let's start with the nuclei. Very simple, easy chapter. Okay. Chalo. All ready? Okay, one people will join. Okay, all ready? Just give me 1 minute. Let's see, bachcho, let's see. Chalo. I just put up a message for those who are there. We'll join it. Starting nuclei. Chalo. So let's see, everybody, what is there in this chapter. The chapter is damn chill, very simple, very easy. First thing, it starts with the size of the nucleus. Size of nucleus. Clear? So we all know who is the founder of the nucleus, who coined the term nucleus, correct? Everybody knows that. Yes, no, everybody. Yes, no. Chalo. Now, Rutherford sir, he discovered it. Okay, very simple, very easy. Rutherford sir, Rutherford, he discovered. Okay. Now, if he did a approximate, if the football is like the nucleus, then the whole ground is the atom. He said the radius of atom is around, you can say, 10 power minus 10, and the radius of nuclei is around 10 power minus 15. Good, Karthike, good. Chalo. So what is nucleons? Nucleus is made up of two particles, two things it has, proton and neutron, both together are called nucleons. Clear? Chalo. Now some basic things, I'm just giving it to you all. Proton, it has positive E charge, that is 1.6 into 10 power minus 19 coulomb. Mass of proton 1.67 into 10 power minus 27 kg. Symbol, how do we write it? We denote it as 1H1, correct? Hydrogen nucleus, 1 proton. That's it, simple. Nothing more than that. Hi, Vinay. Very clear. Good, bro. Next, neutron. What is the charge? Let's do. Charge is 0. What about mass? 1.67, a bit slight more than proton, okay? Symbol 1, 0, and we can show it like this. Okay. Next, everybody knows what is atomic number. What is atomic number? Atomic number is nothing but number of protons. Number of protons and number of electron if it is a neutral atom. If it is a neutral atom. If it is a neutral atom. Clear, everyone? Clear, everyone? Chalo. Next. What is mass number? What is mass number? Sir, mass number is nothing but A is equal to what? Number of protons plus number of neutrons. Clear? Chalo. So, if I want to find the mass of one atom of any element, what I'll do? I'll find mass of proton plus mass of neutron plus mass of electron. Now, I already know mass of electron is nothing but 1 by 1837 times mass of proton. See, so small, so negligible, I can neglect. So, I can do, how many protons are there? Total mass of proton is equal to what? Number of protons into mass of each proton plus number of neutrons into mass of each neutron. So, what we can do? This is the thing, mass of the atom part. So, KCT good mock test. Yeah, we are bringing the KCT mock test. It is there in the app. Okay, you can get the mock test in the app. Chalo. Next one concept comes AMU. Everybody knows what is AMU. We have read in what? Small classes. Atomic mass unit. Tell me what is the formula. Write down in the chat section. Fast, everybody. And define what is one AMU. Let's see how many people remember fast. Nobody wrote about AMU. Chalo, 1 AMU is equal to this value you wrote. Okay. So 1 AMU is defined as 1 by 12th of mass of carbon 12. 1 AMU is defined as 1 by 12th of mass of carbon 12. 1 by 12 of mass of this carbon 12 atom. Okay. Done. Now value you already know. Okay. That is also correct. Chalo. So this much we have done. Now let's come back. These are the basics. Okay. Let's see for the size of nucleus part. Size of nucleus. We know what is that. R is equal to, R is directly proportional to what? R is directly proportional to V is directly proportional to A. So V is equal to what? 4 by 3 pi R cube is directly proportional to A. So can I write R cube is directly proportional to A? Can I write R is directly proportional to A power 1 by 3? Yes or no? So if I remove that constant, I'll get R is equal to R naught into A by 1 by 3. Correct? Clear? Clear? So this formula is for what? Radius of the nucleus. Now next we know density. We want to find the density of nucleus. Density is what? Density is defined as mass by volume. Mass by volume. So mass, let's say I have taken A, volume I have taken, let's say, since volume was directly proportional to A, I removed V is equal to K. So can I write V is equal to K? So see, A got cancelled. So can I say it is almost constant? And the value, like whatever element you take, whatever the element you take, its density will almost be similar to or equal to this value. So whether you are taking a gold or any other, any L, okay, whatever the density, what you are getting is this much. Clear everyone? Clear everyone? So what they're trying to say is the density of the nucleus of an element or an atom is independent of atomic mass. What they're saying? That the density of nuclei is independent of atomic mass. Clear everyone? Clear everyone? Clear everyone? Chalo. Is independent of atomic mass. Power 17. What? Oh, that power of that. Okay, okay. Chalo. Next, we all know about mass energy relation. Mass energy relation. What is that mass energy? That energy can be converted into, mass can be converted into energy. Okay. And in that case, you have to travel with the speed of light. So energy and mass are interconvertible. But we won't go much in that details. So don't worry. Okay. Because we don't get much question from that part. Okay. Chalo. Next, what is the part where we get questions? We get from mass defect and binding energy. We get from mass defect and binding energy. Mass energy is equal to, just I'll put E is equal to mc square. Clear? Sure. Next is binding energy. Binding energy. Now, what is this binding energy concept is? Let me clear. So what happened is, when they brought the nuclei, okay, the nucleus, so they calculated the mass of the nucleus, and in nucleus neutrons are there and protons are there. So separately they calculated the mass of what? Protons and neutrons. So what they saw, that there is no match. These two are not exact. Then they said that something, radioactivity, will just go in slide details. It is not there, but we'll go in slide details. Okay. Chalo. So what it said in mass defect, okay, that there, if I'm finding the mass separately by using mass of proton plus mass of neutron, that is more than the mass of nucleus. How can that be possible? Means some of the mass is getting converted into some other form. So what other form it will be converted? It will be converted to energy form. And what is this energy used for? Holding the protons and neutrons together. We already know neutron are neutral particles, nothing happens. But proton positive particles, how they're overcoming that force, what is it, electrostatic force of repulsion? By using this binding energy part. Okay, and what is that force called? We'll come to that, the nuclear force. Okay, we'll read about that also. So what they found is about the mass, mass effect. They said that the energy is equal to delta m into c square. Okay, and this delta m is nothing but mass defect. What is mass defect? Mass of the whole nucleus, mass of neutron plus proton separate minus mass of the nucleus. If I do that, whatever the extra that mass is missing, that mass is known as mass defect. Clear, everyone? Next, we told that this mass defect, whatever the mass was missing, that is getting converted into energy, and that energy is used to hold the protons and neutrons together in the nucleus. Clear, everyone? Now, to hold all of them, we are using this EB energy, binding energy. What is the energy we are having just to hold one? So what we do? Divide by nucleon. So we get this one as binding energy per nucleon. Binding energy per nucleon. Clear, everyone? Clear, everyone, till here? So binding energy per nucleon is nothing but total binding energy divided by the total number of nucleons. Clear, everyone? Clear, everyone? Chalo. Only Karthik is there or anybody else is also there? Chalo. Hello, hello, hello. Who all is there? Chalo. Okay, okay. Just give me 1 second. Hello, hello, hello. Yeah, students. I think so. The power went off. So, well, for today, we'll keep the class till here. Okay. We'll finish a bit part is left, not much. We'll finish it in tomorrow morning. Okay. Chalo. Keep it till here. Okay. We'll see you all tomorrow morning. We'll finish this and we'll complete it. Okay. Bye. Good night, everyone. Thank you, bro. Tomorrow timings mostly morning will start. Okay. Mostly morning will start. Around 8, you keep it. Morning 8. We'll start, we'll finish all the 3 chapters PYQ one shot. Okay. So 8 to 11, be there, everybody. Okay. One shot, we'll finish it. Chalo.